This is Bryan Hoyer, K7UDR.
So I heard this, I heard Bryan's talk originally about the hailing channel, and it just was one of those whack. This makes so much sense. This is, we need a place, because all the things that I'm interested in are wildly disparate modes that don't have anything in common. They can't hear each other. They can't decode each other. How do you get in communication, especially in this new era of software-defined radios where, okay, I can do anything. I just need to know what specifically I need to do to communicate with X, Y, and Z. So Bryan's solution of the hailing channel, I thought, was really elegant answer to that, and it hasn't gotten nearly enough attention. So now I hope it will get more attention again.
That and a lot more.
What?
That and a lot more.
Okay, great. Take it away, Bryan.
Okay, it's the 90s. I'm in Silicon Valley. I'm a hardware engineer. I specialize in FPGAs. At the time, we still drew them on schematics. That's how early it was. So I had this idea to build a little logic analyzer. So I built the company and built it up over a few years and sold it to an FPGA company. Then I made some money in the dot-com boom, which I later lost in the dot-com bust, but that's another story. So I bought a boat, catamaran, going to sail around the world. Went down to get a ham license because that's how you can talk long distances over water, is ham radio. So I went to a Gordon West 2-day seminar at the Oakland Yacht Club about ham radio. And first off, if you haven't been to a Gordon West seminar, it's a treat. He's a funny, funny guy. And there I met a guy named Jim Corriman. Anybody know Jim? Few people do. So Jim Corriman is a guy who did, what's that program he did? Sail Mail. Because Jim was a sailor. And that's what they used to communicate worldwide. So after the dot-com bust and a few other financial disasters, I sold the boat because I decided I didn't really want to sail around the world, and I decided to move to San Juan Island instead. And I got up here and I still had ham radio. There was an active MCOM group. So I got involved with those people. And we decided to go to the DCC conference in Vancouver, Washington. And Rick Muthing was one of the presenters, that he had done WinLink, which we were interested in. And there I met John Hayes. Anybody know John Hayes? Great guy, great guy. Very, very knowledgeable, big promoter of D-Star. And we got together, me and Basil, my software guy, and we decided we were going to do something in this space. So we put that together in 2011. I'm going to come back to John Langner and talk about him later. So we did that and started this project to make the UDR, the Universal Digital Radio. And that's the presentation that I gave before the one that Steve heard about how we need to get faster communications digitally. So it was an allegedly 56K radio that over the course of a few years, we never quite managed to get it to market. I went to one seminar, and it had been so long that somebody said, what if it doesn't come out next year? I said, well, if it doesn't come out next year, I'm going to light myself on fire. And so the next year at the conference, they brought fire extinguishers up to the podium, and I lit myself on fire. Let's go forward to 2012. What Steve got interested in, a hailing channel for packet radio, WinLink, APRS, and beyond. This is Tapper, DC in Atlanta, 2012. Okay. This is the place I first got to meet Phil Karn, fascinating guy. And I had this idea for a hailing channel. Now, at the time, I had never met Bob Bruninga, but I knew something about him. I knew that he was the guardian of APRS. And we'd had a couple of email chats back and forth before this happened, but I was very, very careful not to irritate Bob. So one time I asked my thing, I said, well, maybe I should do like authenticated to APRS. And my software guy said, it's already been done. So I emailed Bob and he goes, sounds like a good idea. Well, you ought to try it. Okay. So I get my presentation together and I head down to APRS and beyond in Atlanta in 2012. And this is a snippet of that presentation. There's a band plan, 10, 20 kilohertz channels on a 2 meter, 70 centimeters. But how many channels do we use? And the answer is we're generally jammed up on a few channels. So if we want to connect to everyone else, but we don't want anybody else to use my frequency, how do you allocate that? And the answer is you spread it over many channels. But how do you coordinate that? You get a hailing channel. You designate a channel for hailing only and then move your traffic to a different frequency. It's not a new idea. You can do it manual in HF nets, Marine Channel 16. Any boaters here? Boy, I'm getting a brand new crowd here. So Marine Channel 16 is the channel you're required to monitor for emergencies, but you're supposed to contact people on Channel 9. But if you want to do a radio check, what you do is you get on Channel 16, you go, anybody out there on 16? And 16 people will go like, you can't do that on Channel 16. And you say, thank you, loud and clear. Or you could automate it. How does trunk radio work? All trunk radio is there's a control channel. And then the radios themselves, when you click into it, they look at their spare channels and they hand you one. Pretty straightforward. So I'm thinking maybe we could use a channel and use APRS for that hailing channel, and then we could QSY to any of a bunch of different frequencies, depending on what we wanted to do. But there's Bob, and I'm nervous because this is his holy grail. So I get to Atlanta and I see Bob there, never met him, introduce myself, hi, I'm Bryan. And I get to the spot where all we have to do is agree on a channel. And the guy in the back room goes, it's 128.25. And I go, and your name's here? He goes, I'm Bob. And I went, okay, we're done. Use the APRS frequency. That's what it's there for. I felt a lot better after that. Afterwards, Bob came up to me and said, I think it's a great idea. I wish somebody would do something with it. I said, okay, well, we'll see what we can do with that. So if we use, not that one yet. Go back. So what we're going to get situational awarenesses, resources, beacon. It already uses short messages, perfect for that. It keeps traffic short in spirit of APRS. And you can do iGates and RMS gateways at the same time. Now I'm going to fast forward a little bit. So I've got this, stand in front of the microphone, Bryan. So I've got this thing going on in my brain, and we're going to go to another conference, and it's like, what can I do next with APRS? And I'm thinking, has anybody ever done digital signatures on APRS? Certainly somebody has, but I couldn't find it any place. So I emailed Bob, and Bob said, sounds like a good idea. Now, why would you want to have an authenticated message? Well, I'm in NCOM now, and sometimes people put out misinformation, or may not even be intentional, just incorrect information. But if you look at today's environment, and you could have seen this coming down the pike, you also have the possibility of bad actors. People want to intentionally dish out disinformation. And I don't think it's common in ham radio because it's not our spirit, but I certainly have heard people on HF preaching all kinds of things that I didn't think were exactly correct. Another thing we could do is control remote equipment. So I had a friend who had a cabin on a different island that didn't have power, and he wanted to run his generator occasionally. But he didn't want anybody else to run his generator. And that makes perfect sense to me. So by doing authenticated messaging, we could now put a cryptographic pair to where I could control the generator, but if you got on, you'd fail. Okay, so I've got this thing seated, and I've given this conversation, and some of the attendees had heard it. And now I'm over in Dayton, and I'm at Bob's APR's presentation, which is a few hours long, and he's got a bunch of little speakers doing 10-minute slots. So this guy gets up there, his name's Andrew Pavlin. And he gives this presentation. He says, my in-laws gave me a motorhome and it's got this generator on it. And I'd like to be able to turn it on and off to exercise it, but I don't want anybody else to. And there's this guy named Bryan who talked about this that I heard, but I don't know how to get a hold of him. And I said, Andrew, I'm sitting in the front row. Let's talk. So he finished his presentation, which was very well done. And it uses standard cryptography. And he came to me and said, well, I didn't do it the way you described in your presentation. I said, well, let me tell you something. Someone like you who actually does something is way more important than someone like me who just talks about what somebody else should do. So he went ahead and built it. And his first thought of this was at about 2011, but it was like 2015 or 16 before he got to it. So yeah, he had another APRS client, use standard cryptography. It'll do authenticated messaging. You can also use it for remote control. And it's a wonderful free program. Thank you, Andrew. Here's another project that is interesting. So Basil, my software guy, over on Lopez Island, we've got all these RMS gateways. At the time we had over 20 of them you could hit. And then the question becomes, well, we got the hailing channel concept of I'm going to QSY to something else to do traffic. Then the question becomes, which one do you want to use? So what Basil did was he went to the internet. You do this offline before the emergency, right? And you pull down a list of, and you can do it by a radius around me or a grid square, and you get a list of RMS gateways that are potentially in your area. And then you just ping every one of them. And Direwolf has some statistics built into it where you can get back a feedback on, well, first off, did you connect or not? And if you connected, what's the SNR? So you get a real feel for it. He automated this program and runs it 4 times a day. I like 4 times a day because that's how the National Weather Service reports weather, 4 times a day. And weather has a great influence, as well as day and night, on which things you're going to be able to get to. And so it would compile this. Basil's been running these for years. And if we ever had an emergency to get to a gateway, he could pop a list up and he'd get the most current view of the gateways around me, which ones are the most likely to be successful. And then Steve popped up the other day, a couple years ago, and said, now that probably can't read, can you read that? The young guys all said, yes, I saw that. Can the people in the back of the room read it with the glasses? No. Oh, okay, good. Anyway, Steve came back to me and said he wanted me to redo this presentation for the hailing channel at Seaside. And so I did that a couple years ago. Didn't go this year, but I went last year, gave this presentation. And introduced me to the new APRS Foundation, which I hadn't heard of. But I went and checked them out and I liked them, and I joined the thing, and one of their goals was to formalize specifications in a particular format. Those slides are out of order. Curiously, a number of years earlier, I noticed that I would go to these conferences and people would talk about how they did something, and everybody told the story differently, and it wasn't archived like they're talking about now. So I thought what we really need is like a clearinghouse. So I formed the Amateur Radio Engineering Task Force, not coincidentally like the Internet Engineering Task Force. And it was a place to gather standards with a common framework. Now, that didn't go anywhere. But the APRS Foundation does exist, and it came about after Bob passed, because they wanted to do some things to preserve the great work and the great power that APRS has. And the first thing I did when I went to there that I liked about them is they referred to it as the Automated Packet Reporting System, not the Automated Position Reporting System. In another talk I did about APRS, I pointed out that when Bob invented it, it predates the common usage of GPS. When Bob said position reporting, he said, well, you're at a race and you want to say they're down by the red barn. That was position reporting. but you could do much more with it. As a note, I pulled up what year we had the first, quote, handheld GPS. And it was bigger than this. And Magellan made it. And it cost $3,000. And that was after Bob had invented APRS. So clearly, it didn't come out of GPS, it went the other way around. Once we had that power, though, and the cost came down and down and down, then it became practical to do that. So, APRSfoundation.org, I think it's good. I have one problem with it is they want everything in the IETF format, and I don't speak that. So I'm now looking for somebody like Andrew Pavlin, who is a software engineer, who does speak the language, and see if he's willing to help me to get that put together so we can get it specified. Any questions so far? Yes. 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 Interested? Do you know somebody? It's okay. So the internet side, RFC is request for comment, correct? And the way it works is you write something and you submit it to the body, and then everybody on the body looks at it, and then they tear into it. I mean, pardon me, they give you positive comments on how it should be done or can be improved. So it's an iterative process to nail down things. And it's sometimes awkward, but from what I've told, it results in things that are very well thought out because you get a bunch of different people from different backgrounds all giving you positive comments about things.
Yeah, one example of an RFC would be like the 10 nets that you use for private addressing. That would be RFC 1918.
Okay, thank you.
Email was RFC 821 originally.
Okay. Right, they get numbers and are signed and everyone knows about it. And then as a network of manufacturers, we do the same thing the same way. Which is one of the problems with more ad hoc things is 4 people will do the same thing 4 different ways. And that's why when it gets to things like authentication, use standard cryptography as is used on the internet. Let's not invent anything for ham radio. All right, let me back up a little bit. In the beginning, I mentioned 2 silent keys, John Hayes and John Langner, the 2 Johns. Coincidentally, what's that? 2015, according to the internet.
I
Is that not true?
think that's not, I don't think that's correct because QRZ says no.
That's good news. So much for AI again, which for me stands for automated idiots.
Sorry for the internet people. The rumors of WB2 OSC's death have been greatly exaggerated.
Thank you. So coincidentally, John Hayes and John Langner. Now I verified that John passed away last year, but John Hayes and John Langner were both in the same radio club back in Massachusetts back in the day. So when Direwolf came out and we started to use it, I asked John to ask John that we would fly him out to the West Coast. We'd give a presentation on it. So I believe that was one of the microhams. I forget which one, Steve, but one of the microhams we invited John Hayes to come out.
It was a microhams.
What's that?
It was one of the microhams digital conferences.
Okay. And it's fascinating. So I have done some accidental stumbling into how good Direwolf is. And I've got 2 cases. We had a device called the UDRC, which is a Universal Digital Radio Controller. It's a Pi hat. And it had a mini DIN 6 on the back of it for a radio interface. And I built it specifically for John because John was a big D-Star advocate. And Yaesu was brought Fusion out, and they were giving, repeaters, 2 radios inside a case away for a really low price. And John said, Bryan, if you gave me a little bore and a pie, I could take the Yaesu repeater and modify it to run D-Star. And I said, I would definitely do that. Because earlier we had just gone through, Steve was there, an absolutely horrible presentation by the Yaesu sales guy about how wonderful Yaesu Fusion was. Remember this, Steve? He got torn to shreds. It's horrible. This is the one down in Seattle. Remember? So he got torn to shreds. But, I just thought the fun factor of, because I'm a believer in why do we all, I'm going to repeat myself, why can't we all do the same thing the same way? Thank you, Tina. And the answer is, why did Fusion have to be different than D-Star? And the answer is because the families, and I get this on good credit because I know some of the executives at Icon. So they told me the story about how the 2 families were in a fight over this in Japan. So it's like, why do we have to reinvent the wheel all the time? Why can't we all just get along? So I built this card, and yea, verily, people would buy these cheap Yaesu repeaters, and then they get a pie and we convert them to D-Star. You could do either one, but your choice is your choice. In the process of doing that, I looked at my card and I was about to spin it, and I said, I've got a codec with 2 channels and I only have 1 connector. I should put a second connector on it. So I did that. And when I got the first batch back, I went to test it. So I plugged it into a radio and I put it on the APRS frequency because that's a guaranteed continuous traffic to see. And I'm getting packets, but not that many. And my CPU usage has gone through the roof. Direwolf is working really, really hard to get these packets out. When I can turn my radio on, I can clearly hear them. Well, I plugged the cable into the wrong connector, so there was no radio on that channel. And Direwolf was decoding packets out of the audio leakage in the inner channel. And I thought, that's really impressive. So I moved the cable over, and then packets came screaming out, and the signal noise ratio went way up. Good deal. So later, I told you about Basil's project to go out and post all the gateways. I'm looking at the list, and we got all these gateways out there. And I'm looking, and there's one, the signal noise is really, really terrible. But it was managed to copy it. And I look at the call sign, I go, well, hell, that's my repeater. And it's not on the APRS frequency. It's 3 channels away. Yet Direwolf, once again, CPU cycles like crazy, was able to decode packets from a repeater which was 3 channels away from the APRS frequency. That's how good it is. Thank you very much for your time.